So now we're ready to mount this onto the bike. The first thing we're going to do is take the adapters or accessory kit out, set it out of the way. We're then going to take the bracket, set it up. The pins that I'm putting in now are ultimately going to end up in the swing arm pivot. So we're going to put one in here and one in here. These are the little handles that cinch these or locate these into position. All right. We're now going to guess that that's about how big this bike is and go ahead and put this on. So that's on, nice and tight, and that's complete. The next thing we're going to do is plug that in so it has a moment to get ready to do the measurement. All right. The Max system runs on 12 volts DC. Which is really great because a lot of times if you have a laptop computer, which your system comes with, we have a set of jumper cables that come in the kit and you're actually able to measure the bike with no external power source whatsoever. Instead of plugging it into 110, you would actually jump it off the battery and you could measure a bike in the middle of a field if you had to. So I'm going to go ahead and plug this in now. Okay. The next thing that we need to do is, this is the target bracket for the Max system. So we're going to go ahead and mount this onto the bike now. Okay, so this piece of all thread happens to fit through here. And we're going to hold that in place with a nut on the bottom of it. So that's tight now, and to ensure that it's tighter, we're going to take our scissor clamp and we're going to put this on. And we're going to give this a little more of a snug turn. Now, what the Max system needs is it needs something to project this axis 160 millimeters forward. This piece here is going to be the piece we use to do that. And we've got this roughly square to our fork tubes, roughly, no big deal. And here's our double target bracket. And we're going to put this on. And we want this roughly straight up and down. Doesn't necessarily have to be perfect. Nothing's that fussy. Then we're going to take and plug this in. Now what we're going to do is plug the USB cable into the Max system and begin to check our mounting. All right, so now we've got our target bracket affixed in the front. This is our double target bracket. And what's going on here is that there are two infrared lights behind these two white patches. And what these do is these shine a light back at the Max machine that moves with the steering head. And this is just a static point because this is very solid, or certainly solid enough. And those let the Max see 160 millimeters in front of the shaft. So what those brackets, what that target bracket is shining back at is this is a camera and this is a camera. The Max machine knows how far it is to the swing arm pivot, and how far these are apart. From that, it's able to triangulate and look up at the target brackets, which are shining back at it, and it's able to measure in 3 dimensions because of that. Okay, so to begin the measurement, what we're going to do is we're going to choose the icon on our Windows computer. Then from there, we're going to go to measurement, which is what we're going to do, is measure. From there, we're going to be in the database, and we're going to select which motorcycle that we're going to measure. That's not necessarily important in the beginning, but this is the template that we will measure the bike against, so we might as well pick the one that we're going to measure. So here we are, we've gone through the A to B to Z, so now we're on the Suzuki's. And by capacity, we see that this is the 1000 cc's, and we're going to select this, and there it is. So we've made our selection, and now we're going to start the measurement, and now we prepare the rigging. So what we're looking for here is that our dots would be in the center of the screen, and it coincidentally turned out that this is centered up. But what we would do is we would move the bracket, and if you see on the screen there that when we move the bracket, the dots are either higher or lower. If I move this like this, I can make them go lower as well. So that's what we want to do, is have something roughly in the center, nothing fuzzy, within 20-30% of the center is just fine. The second thing we would like to do is we would like to turn the bars, we're all the way to the right, and we see we have a margin on this side. And we will turn the bars now to the left and make sure that we have a margin on this side so that we know that our dots are sort of in the center and there's a border on each end, and so we know it's okay to start the measurement. So we go to the OK button or the Proceed button. So we read the top of the screen and it says, please make sure targets are visible to both cameras. We've already done that. We press the Proceed key. It says, please turn the fork to the left. We've done that as well. And then now we're actually measuring the motorcycle. So this is how long it takes it to measure this spot. What it's doing is making sure that it is getting a repeatable measurement. Once it does that, it tells us to go to the next step. It's telling us to move the fork to the right. We're doing that now. You can see the dots sweep across the screen. That's been accomplished. We're going to press the OK button or the Proceed button, and now it begins to measure these dots in this position. Now what it's asking us to do is turn the bars back to the left again to verify that nothing on the rigging has moved. It doesn't need to necessarily be in the exact same spot again, it just needs to verify that it is within the arc and could in fact, and it does in fact mean that nothing on the rigging's been compromised. If something had moved, there would be an error message on the screen saying that something was unstable and that needed to be repeated, and of course it would make you start from the beginning again because that's the only way to ensure an accurate measurement. So now I'm going to mount the height post, and this is our height post, and what we're interested to do now is one of our reference points for the measurement is that this would touch the bottom of the casting by the steering head. So we're going to go ahead and move the bar out of our way. And then on the scissor clamp here, we're going to put this on. So let's do that. So we're going to slide this in. And this is going to fold up nice. We're going to tighten the Allen on the other side so that it won't move. And then we have a spring and a little clamp that helps hold everything in place. Then what we're going to do is we're going to use our single target bracket, and we're going to stick this into this tube, And basically what we're doing with the Max machine now is we're allowing it, because it knows how long this tube is and it knows where the target is, now it's able to mathematically decipher where the bottom of the casting is. Sure, we've got that pointing back at the cameras. We plug it into the power source and we have our dots. On this one, there's no measurement. The fact that it's below the center is absolutely acceptable. And we're going to go to the next step, so we're hitting the OK button. Okay, what you're seeing here is it's telling us now to position the laser at the left side of the swing arm axle and then press OK. What we're going to do is we're going to use this right here and butt this end up against the frame, line our laser up against this line, and what that's going to do is tell the Max where the outsides of the frame are, and by doing that, we don't need to worry about putting the Max on and making sure it's exactly centered. So I'm going to go ahead and do that now. So once we've done it to the left with the tool, we're going to press OK, and it's going to ask us to go to the right. Now that we've done that, the initial part of our measurement is done. So what I would do is the forward step would be OK. And then we wish for the results. Okay, so our measurement is concluded at this point, and we have our results here. Camber would be the lack of perpendicularity between the swing arm pivot and the steering head axis. That shows us that it is 0.04 of a degree, which is absolutely just fine, no big thing there. You're allowed 0.3 of a degree, and this is 0.04 of a degree. The steering head angle is exactly nominal, so there's no deviation from the index data whatsoever on that. The length of the frame, which would be length A, which I'll show you in a second, is 1.9 millimeters longer than it should be. Length B, which would be the vertical representation, I'll go over that in a second, is exactly nominal. And we see that our lateral offset to mid-plane is 0.7 of a millimeter. The next thing we would do on this is we would print this out. So if we go to print out, and I can actually show you what this looks like. So we're going to maximize this. So here's the actual printout that would be printed out on a piece of paper. And we haven't done a tail measurement or a swing arm measurement on this, which we'll show you in another part of the DVD. But basically what this is going over is you have two planes. You have the horizontal plane of the swing arm pivot, and you have the vertical plane of the steering head. Again, camber in this case is 0.04 of a degree minus. So if we look, we see that the minus sign is on the left or counterclockwise from the rear view of the bike. So it's counterclockwise 0.04 of a degree, which is very, very nominal. The steering head angle, as we see, is the angle in relationship to the A and B measurement. This has nothing to do with geometry of an assembled bike, which is a gestalt of front and rear ride heights, tire sizes, things of that nature. But we do know that at a length A of 645 millimeters and from a B dimension, which would be the vertical representation up of 317.6 millimeters, that angle should be 24.80, and it is. So this is just at what you would expect from a 05 Suzuki that hasn't fallen down yet. It's a very, very nominal bike. Shows that there's good manufacturing techniques employed by Suzuki, and it's a very straight bike that has not been compromised in any way, shape, or form.